but it can be produced too. Now finally, nitrogen-14 and oxygen-18 give beryllium-9, which is a stable isotope of beryllium, the only one, and some sodium-23, only one stable isotope of sodium. And if you continue this process pairwise, as you go all the way across this periodic table, you see how we're filling it in? You can create all of these elements in the periodic table all the way down to the last stable element in the periodic table. All of the isotopes of every stable isotope. The whole periodic table being created from the hydrogen and the oxygen in water by a valid scientific mechanism. If you're interested in details, most of it was published in the last ICC conference, at least through not the whole table. We just recently finished the whole table, but the basic in-depth portions of the process are in that publication. If you're interested in that, or if you know how to comprehend that. And now we've completed the whole table. I'm trying to resurrect what I had left from the flood, and fortunately it was on a computer. I can at least get the results out and hopefully have it published. And we'll have this question of origin of elements from an entirely different perspective, totally in agreement with the biblical perspective, and it works out like it should, you know. Science should be in agreement with biblical authority, right? We should not have to stretch anything, okay? So working from first principles and using the tools of science, we proceed and build up all the periodic table of chemical elements. And that's the truth, as some people would say. Okay, that's basically it. I think we... Yeah, sure. Any questions?
I realize that these all look good on paper. Have people gone and actually made the different elements?
You can't create...
Big Bang breeder reactors both look great on paper, but...
You can't create those conditions.
Please repeat the question.
The question was, what looks good on paper, can you actually do this in reality, you know, experimentally? And the problem is, you can't create a plasma condition of 10 billion degrees. I mean, they can create plasmas, you know, of, I don't know if they can even do 1,000,000 degrees right now, but getting close to it, you know. But there's just no mechanism, no environment to do a laboratory scale, so you can never duplicate this in the laboratory. Not unless something comes along in plasma physics that we don't know about, but yes?
What's the temperature equivalent of a billion electron volts?
Let's see, the temperature equivalent of, trying to remember now, 1 million electron volts was, I think it's close to like 10 to the 10th Kelvin. Like close to 10 to the 10th Kelvin, that order of magnitude.
What happens to all the electrons and how do they get back into the...
Well, see, in a plasma, all of those charged particles are agitating, constantly, you know, swirling. So the negative electrons are finding themselves in a certain region, whereas all the positive particles are, and I envisioned it more like a separation, that the electrons are, while the processes are going on. See, you'd have to drop the energy considerably for those electrons to attach themselves to those nuclei. So under that very high energy, they can't be attached. But they're still there.
But when it cools, they...
Then as it cools down, they'll come back and form the stable atoms, yeah. Yeah. In fact, that's the way plasmas are. Yeah, Bill?
Are these reactions similar to the ones that the evolutionists think were going on inside the stars to create the heavy?
No, they got a whole different scenario. They've got all sorts of schemes. Oh, no, they start with particles. You know, they build a hydrogen atom from the basic particles, and then a helium atom, and that process in itself takes a billion years or so, you know. And then it goes on from there. Also, all different domains of reactions, different heat conditions, and time factors involved. If you ever look at any nuclear chemistry, we'll call it stellar chemistry, it's very confusing. I mean, they break it down to all sorts of... I talk about that a little bit in the publication, about the basic divisions of the evolutionary model. But it's quite complicated. They don't even get some of the light elements stable until later on. In fact, there was always a big problem on trying to create something like beryllium. I mentioned beryllium-8 would fly apart because it's too unstable. It'll produce two helium atoms. And you couldn't get that from a normal, adding neutron process, that kind of old idea that was produced. Who was that produced by? I can't remember right now. Popular name. I can't think of it. But anyway, it was then they imagined that there was some other process with heavy nuclei that went through a spallation and created the lighter nuclei after. Yeah.
Is this process that you've just presented, starting with the water molecule and producing the entire periodic table, is that completely unique, or could you construct a similar process with a different kind of initial molecule?
Well, if you knew what to use, I guess you could start with something, yeah. I mean, the process itself depends upon having some nuclei available and get them to start to fuse and combine.
Like, for instance, could you just start with hydrogen by itself?
Hydrogen by itself? No. Not get it within the time frame. No. Remember, the time frame is very critical here. We're trying to be in agreement with 3 days of creation